Okay, in this video, we're going to look at how to find derivatives or take derivatives using the chain rule. Okay, so with the chain rule, I have the derivative of something that has a variable with it, so some function, and then I have it to a power of n, so some number there. And when I take the derivative, what's happening is the n is coming in front, it's getting multiplied by whatever's here, and since there's a 1 there, n times 1 is n. The inside is staying the same, you see this f of x matches, and then we're subtracting 1 from the power. That's my general power rule, but because I have stuff going on inside, okay, I have to multiply by the derivative of the inside. So the derivative of f of x would be f prime of x. Now, you can memorize it this way, you can memorize the notation, but for me, I like to think of it in words, so I can just repeat a phrase in my head a few times and then I have it memorized. So what we're doing is the derivative of the outside, so whatever's outside my parentheses, inside is going to stay the same, minus 1 from my power, times the derivative of the inside. So I'm going to show you what that looks like. So when we take the derivative of y, we get dy dx. Now, the only thing I have outside here is this exponent that's a 4. So the derivative of the outside is going to be bringing the 4 in front. The inside stays the same, exactly, minus 1 from the power, which is going to give me a 3, and then I have to multiply by the derivative of the inside. So I'm going to multiply by the derivative of 3x squared minus 2x to the 5th. And since there's two terms, I want to put it in parentheses. So the derivative of 3x squared is 6x, and the derivative of negative 2x to the 5th is going to be negative 10x to the 4th. And that's my derivative. Now you can write these in any order. Sometimes you'll see me put the quantity, the parentheses here that doesn't have a power in front. Okay, so that would look like this, and then I would bring down my 3x squared minus 2x to the 5th cubed, but it doesn't matter. Both of these are correct. You generally won't see me write the dot if I have the parentheses there. Some people will distribute the 4 through to this one, but I don't see a point because a lot of times in other problems we need to simplify, and we may have to bring a greatest common factor or something out. In fact, I could take a greatest common factor out of the 6 and the 10 and bring it in front. Okay, so you're going to see it in different forms, and you just need to be able to manipulate it. All right, let's look at this example. Well, this is a square root. And so when we do chain rule, we really just kind of want to write everything as parentheses to a power. So you should know that I can rewrite a square root as the inside to the 1/2 power. That's what a square root is. So it would look like this. And now I'm just going to use the same rule as before, only I have a negative 3 here in front. So when I do dy dx, I'm going to do 1/2 times the negative 3. Which is going to be negative 3/2. Inside stays the same, minus 1 from my power. And when I subtract 1 from 1/2, I'm going to get negative 1/2 times the derivative of the inside. And the derivative of the inside here in parentheses, because there's two terms, is going to be 20x cubed minus 1. Okay, so now that's correct. And a lot of times you'll see me leave it like that. If I did want to simplify it, there's several things you can do. I see that this has a negative power, so it's going to ultimately end up on the bottom. So this is a fraction already. I could put the negative 3 on top, the 2 on the bottom. This would stay on the top. And then I could move this to the bottom, and I could write it as 5x to the 4th minus x to the positive 1/2 power if I move it to the bottom. Or I could change it and write it back as a square root. Any of these is fine. I don't necessarily need you to be able to keep it in a certain form or to simplify like this all the time. But if you were doing something that was multiple choice and this was the answer given, you would need to know that yours is the same. So it doesn't hurt to move things around and try different things and write it in different forms just so you recognize those. Okay, last one here. We do have to know our trig rules for this. If you need to go back and review that video, do that. This is sine cubed of 5x squared. You could also see this as sine of 5x squared cubed. That's really what's happening here. So I have to understand that because when I use chain rule here and I'm taking the derivative of the outside, that means bringing this 3 in front. So the 3 will be in front and then everything that's in here will stay the same. So I will have sine of 5x squared. Now, I'm going to subtract 1 from this power, which is going to give me 2. And I could write it like this, but we know with trig that we're going to write the 2 there on the sign, okay? So 3 came in front. Everything inside stays the same. Subtract a power, which gives me the 2, times the derivative of the inside. Now this is where it's important to know our trig rules, because the derivative of the inside means I take the derivative of sine, which is cosine. This part will stay the same. And then I still have to take the derivative of the inside of that, which is going to be 10x. So what I did, guys, was when I take the derivative of the inside of this, right here, just this part, I used trig rules. The derivative of sine is cosine, inside stays the same, times the derivative of the inside. So that's essentially, we're kind of using chain rule twice, because trig functions is a form of chain rule, okay? So you just have to be really, really careful. This is my derivative here. Again, I can simplify this a little bit. I might do 10x times 3 to give me 30x, and then I would have sine squared 5x squared times cosine of 5x squared. I could write this in a different order. So just, you know, this is fine to leave it. Sometimes it's nice to write the 10x times 3 in the front, make that 30x, clean it up a little bit, but that's up to you. Okay? Review any of the videos that you need to, and I will see you next time.